It's either in your states already or in the pipelines, right? So please don't kill us. We're just trying to help you guys out here. At the same time, this is going to be like a 10,000-foot view. If you guys have if we don't answer all your questions, please contact our tech services. Tech services will be able to assist you and also probably give you some resources you need to get more in depth with ASCE 7-16. And also look out for future webinars coming out that might get more into the thicket with the code that might be able to help you out a lot more. And last but not least, Mr. McCabe right now in the chat box is actually putting a link. This link is pretty much a 61-page PDF that our great Miss Joan Crow actually wrote. Pretty much is a guide to using ASCE 7-16 for Everguard TPO and PVC roof systems. So that's something that we've been using, Wally, since we try to learn this stuff, right? Because it gets kind of complicated a little bit, so you constantly keep looking at it, looking through it, and you always catch something new, right? And also, guys, us care and the care team, we always try to give you as much information as we can. Anything we could give you guys to pretty much you could take from our classrooms to the field, try to give you all the answers possible. But with the ASCE 7-16, it is very, very hard for us to give you a carbon copy of what you need for your fastening patterns. There's too many variables on this for us to give you solid answers, right? But we are going to show you who you can go to or links you guys could use to give you all that information you guys are looking for. Pretty much that's all, Mr. Brown. Did I miss anything?
I don't think so. Somebody just raised their hand on me. That's cool. We'll get to it
here. Get in a sec. Yeah. So, guys, just once again, I want to introduce everybody that's on the panel today. That's going to pretty much talk about the new code. And with me right here, been having the pleasure, been able to work with them for the past year. Once again, TPO and a roof guru, also a field inspector in your previous life, and installer. So, one and only Mr. Wally Brown from Roofing It Right with Dave and Wally.
We've been stuck together for a year in this building, every day.
He's aged pretty bad, guys. I don't know how. I've been a pleasure of working with. And then the next guy is the workhorse, the guy that pretty much does all the legwork for these webinars, that gets all these beautiful presentations ready, pretty much organizes everything. Hardworking Mr. Stephen McCabe. Take it away, Mr. McCabe.
Thank you, Chino, and I would be remiss if I didn't mention Chino. Chino, if you were here the last couple of days, you know that Chino came from the field, installer, foreman, project manager. He ran crews, and you know his modus operandi was always how to install it quicker, but the right way. And he's really passionate about doing it always the right way. And so maybe that's why Wally's got gray hairs, because he always wants to do it the right way, right? Right, Chino?
Oh, he's getting up there in age, buddy.
So, with that said, we're lucky to have him. When he joined JF a few years ago, he was an inspector, so you got to see the good, the bad, the ugly when it came to roofing. And now he's on the care team. So, Chino, lucky to have you. And, of course, Wally, you know, man, we've gone way back, so always great working with you. So, with that said, we're going to jump right into the mix, is ASCE 7, okay, adoption. So, you can think of the uplifts, the layouts, that type of thing. A lot of it's correlated to ASCE 7, which is a standard that is created, okay? IBC, International Building Code, is basically that's the code that's created by the International Code Council. And they're like the big guys. So one nice thing about IBC is that no matter where I'm at, if I'm in Florida, Illinois, Texas, I can look up the same number in the same section, and I can know what's in that code or not. But you have to be cognizant of what year adoption it's adopted. So as you can see here, the IBC 2006 had ASCE 7-5. In IBC 2012, they adopted ASCE 7-10, and lastly, IBC 2018 adopted ASCE 7-16. So those states that currently have a statewide code, okay, and have adopted ASCE 7-16, you can see here in blue. Okay, so this is the code in those areas. So you want to be definitely cognizant of that, because this is what you're supposed to be installing it to. And remember, like Chino says, we can't stress it enough. We did not come up with this. This is not our baby. We're just trying to get that information out to you. Now, even though maybe your state is in a red, you have to realize that your local jurisdictions may be following it. So, example, I heard Houston, Texas is following the ASCE 7-16. So you want to look at your local municipalities, your county codes, make sure that you are following the correct information. So to give you a little background about ASCE, they based a lot of their wind uplift in their design based on wind speed maps. So the first one, ASCE 7-05, that you see on the screen is based on allowable stress design. And then in the ASCE 7-10 version, they came out with, it's based on the ultimate design in risk category. And there was only 3 wind speeds at that time. Now ASCE 7-16 has a wind speed for each risk category. So if we take a look at those categories, you see risk category 1, farm animals, that type of thing, sheds, farm buildings, that type of thing. Anything that's not a concern with loss of life may be downgraded to the category risk building, category 1 risk building. So that's kind of the first one. Okay. Now I want to call your attention to southern Florida. It's got 170 miles per hour. So with that said, is you can see with that 170 miles per hour, it's going to change as we look at the different risk buildings. So type 2, which is our standard commercial building, whether it's a bank, a grocery store, whatever it is, that wind speed is going to be increased, right? And so you can see southern Florida, it's 180 miles per hour. Then we go to category 3, which is a school, a university, that type of thing. Now we're bumping up to 200 miles per hour. And then finally, category 4 is the emergency, loss of life. So maybe a hospital, fire department, or if it's an emergency shelter, that type of thing. So that would be a category 4. And you can see the wind speeds are increasing pretty much in every map that's shown there. Now, Chino, we've kind of talked about a little bit about ASCE 7-5, 10, and I know most of the country's still kind of using it. GAF, our specifications are based on that. Maybe not exactly, but it's based on that. So can you kind of go over what our requirements are when it comes to that?
Yeah, brother. So guys, just like a quick little review with 7-5 and 7-10. So once again, this is what we're used to. This is what we've been using, right? So one of the big changes with 7-10 to 7-16 is, if you guys can see our template on the right-hand side, we have 3 zones, right? We have our field, which is zone 1, our perimeter, which is zone 2, and our corners, which is the zone 3. So the two big changes for me, one is the corner is square. It squares up with our our perimeter, and also it's 3 zones where typically you could actually run into 4 zones with 7-16. So once again, keep a reminder on this. Take a look at this once we show you the new 7-16. Now, when we're dealing with these roofs, we got to go with our math equation, right? Which is right here on the left-hand side is 0.1 times the building width, or 0.4 times the building height. Now, whichever equation is the smallest, that's where you're going to go for your perimeter. All right. With 7-16, we no longer deal with the width of the building at a certain height. We only go with the height of the building. Okay? Now, what's up top, once again, Mr. McCabe. Oh, sorry. So, well, for example, here, guys, where are we going? Where are we going? Right here? All right. I was like, hopscotch here. All right. And the last thing, guys, is just our fastening pattern, right? For our ISO, 1-inch ISO board, pretty much our fasteners is 6, 9, 12 fasteners per board. If you want something higher, it goes all the way up to 15 fasteners per board. Once again, ASCE 7-16. Might change that up a little bit, but once again, Mrs. Joan Crow will talk to you guys about that on her side. But all right, Mr. McCabe, I think I'm good. So right here, guys, once again, please do not kill the messenger. When I saw this, it blew my mind. So here on our 7-10,
I think he's got pictures of that on here.
I think so. Yeah. On 7-10 here, guys, and if you see the fine print at the bottom, this is based on the height of the building, not the width. Okay. So on a building that's 41 feet high, your perimeter, the width of your perimeter is 16 feet 4 inches. Now our ASCE 7-16. For that same building at 41 feet high, our perimeter just grew to 25 feet wide for our perimeter. And it's, like I said, Wally and I, when we saw this, our heads exploded, right?
Especially got guys in the field who are looking at this and like, holy crap.
Yeah, it's a lot of work. It's a lot of labor that actually has to be included now, right? Well, we were used to this part. Now we got to move over here. And myself as an installer, as a contractor, I'm like, crud. That's more material, more labor, right?
Guys, the whole thing on this is, Joe might mention this, is roofs weren't blowing off. Mainly it was an installation issue why roofs were blowing off. So again, we're gonna hear this a lot today. We did not come up with this. Okay, we just something as an industry we're gonna have to deal with.
Thank you, sir. All right, Mr. McKipp.
So one of the things, if you notice, we have it cut off at 60 feet. So once the height of the building is greater than 60 feet for ASC 7-16, then it's going to be based on 10% of the width. Okay, that's a little confusing. If you were on yesterday, I commented on 10% of the width, so 40% of height. No, this is purely at 60 feet or taller. It's going to be 10% of the width. Now, you may think that's easier, but you also have to be aware that you're going to have a higher wind uplift requirements at that moment in time. So they're going to beef it up, and so you really got to be cognizant of it. So hey, well, we're not giving you a concrete answer, and especially when you see our expert come on later on, you'll understand why it's not just black and white. Hey, this number of fasteners at this moment in time or this place. So stay tuned on that. Now, Wally, as he said, his head was blown away. Oh my goodness, how could they do that to me? Right? I mean, that's what he was saying. How could they do that to me? So the only thing I can say is if you can know the formula, you're way ahead. Once we were able to wrap our heads around the formula, we were good to go. So the formula is going to be for zone 3, it's going to be the height 0.6 times the height. So whatever the height is, 0.6 of the height, that's going to be the length of zone 3. And then I'm going to take 0.2 of the height, and that will be the width of zone 3. And that's our corners. So as you can see blown up right there, you can see 0.6 of the height. That's going to be the length of the zone 3, and 0.2 of the height will be the width of the building. So now, zone 2. Zone 2 is going to be 0.6 of the height. Okay, so as long as we can remember, pretty much most of the formulas are going to come down to that 0.6 of the height. The next one is zone 1, exterior field. That's going to be 0.6 of the height. Okay, so you can see here on the bottom, I've got zone 2 and zone 3 being shown at 0.6 of the height. Whatever that is, that's going to be the size or the width of those zones. Now, you'll notice here that there's this weird thing here called 1 prime. Well, 1 prime is going to be whatever is less. Now, that may or may not come into being relevant to a job, but maybe on a large enough job, that 1 prime may mean fewer fasteners or a smaller fastener or less fastening pattern, so you can decrease the amount of fasteners. But once again, that's going to be on a job-by-job basis, but it's something to keep in mind, especially if you've got a large job. So we'll kind of talk about that a little bit more as we go on. But now, when we talk about this, Chino, here is the formula we just went over, but you kind of still wanted to go over the exercise, so I'll turn it over to you right now.
So, real quick, Stephen, what was that
We
again?
had a question from Jack. I'm not going to try to pronounce that last name.
That's
About the wind maps. We'll answer that real quick. He wanted to know we get a version of the maps. He's had trouble finding one that's big enough to be useful. Stephen, you probably answer that better than I can. Was there any way he can get a bigger map? I'm not sure what he needs it for. Maybe you read a number, read the speeds better, because I find it hard to read myself. So
Yeah, we'll try to get you a link for that to get that, Jack. So I was going to try to work on that, and while these guys were talking. So
okay, sorry.
So real quick, guys, what I have here with like the two differences, you guys saw them, right? With 7-16, we're working with that L shape now. It's no longer square, right? And at the same time, we saw 4 zones. Even though it says 3 zones, it's technically 4. You could run into 4 zones, right? So once again, guys, to me, it's repetitiveness, right? Well, we've constantly working with this, changing the height of the building, everything. So, for example, here, guys, on the building height we have here is 30 feet high. I'm going to totally forget about that 125-foot wide building. I'm not even going to deal with that, right? So what I'm going to do here is do my equation, right? So I'm going to...
Hang on. If you guys have ever seen Chino do math, this is very impressive, so pay attention.
I might get a nosebleed, guys, so don't get ahead of me.
You start taking your shoes and socks off, start going.
So, guys, so first thing I want to do is want to get the L shape of in the corner, right? So I want to get my measurement from the corner going towards the center, not center of the roof, but the edge of the roof. So what I want to do first is I want to multiply 0.6 times the building height, right? Which the building height, again, is 30 feet. Now, am I going to give them the answer really quick, McCabe, so we can move this a little bit faster?
I think
Right?
that's what you said, right?
Yeah. So once again, guys, 0.6 times the building height, my equation is 18 feet. So that's the length of my L shape, okay? Now I want to get the width, all right? To get the calculation for the width, once again, like Mr. McCabe said, I'm going to multiply 0.2 times the building height, which is going to give me 6 foot wide, okay? So my L shape, once again, is 18 feet long on both directions away from the corner and 6 foot wide. So now what I want to do is work for my next, which is going to be my perimeter. So my perimeter of the equation, I'm pretty much going to do the same thing. It's going to be 0.6 times the height, which is also 18 feet wide. So that's going to be my perimeter. Now, before I move forward, this is something that I kind of always recommend guys to take a look at when they're dealing with this. So if you guys are doing your equations, and if you guys could see the length of my L shape should match up with my perimeter. As you can see, Mr. McCabe's drawing that out. So if you guys are doing this and for some reason your L shape is longer than your perimeter or vice versa, you guys did your math wrong, so we got to figure this out, right? We've been doing all these little sketches on these little mock-ups for you guys, and it's been a couple times that we noticed that, so we know we did something wrong. So we need to fix that. So that's something you guys want to keep an eye at, especially your boys out in the field, okay? So now what I got to get is my interior field. So for the equation, exterior field, which is going to be, again, 0.6 times the height, which in this one is 30 feet, is once again 18 foot wide. So Mr. McCabe's putting it up there. Now I got a question for the class, Mr. McCabe. The other ones, we had them actually doing the equation for us, but we have a lot more to show and tell today, so that's why we need to cut it kind of quick. So my question to the everyone in the class or on the webinar: what's the equation for me to get the field? Do I have an equation to get the internal of the field?
Prime 1.
Prime 1. 1 prime. Is there a math equation I need for that? Yes or no?
No, there you go.
No. do not need it. Correct. Right? Whatever's left over. Now, here in this, guys, we do show you guys the prime and the exterior of the field. On our mock-ups here, we did have a zone prime, but it was so tiny that for us, as being being used to being contractors, it was just too much. It just made no sense for us to make it a very small prime, so we just did the whole thing as an exterior.
So, which brings up a good point, Gio. If you ever run that situation, you can never go under whatever your equation is. You can always go over. So our little prime one, we probably didn't need all these fasteners, but it was such a small area, we just said the heck with it and just did the extra fasteners.
Because at the end of the day, what we wanted is what's easier for our guys out in the field,
Exactly.
right? Because it's easier seeing it from this view.
Said the other camera died.
My other camera died.
But
All right. So it's easier from this view where compared to the other one is not. So that's why we want to keep an eye on that. McCabe, can you see me on both cameras, brother?
Just the one.
the iPad, you can't see us on?
Which one can't you see me on, brother? I'm sorry, guys.
Yeah, we can see you waving right now. Can't see you on the one that's going to be, blown up the mock-up.
Okay, I'll get on that right now. So any questions with this, guys?
Now,
Anything?
Wally brings out a ray of light, right?
Yes. So, Wally, take care of that so I can fix my camera here, brother.
All right, guys. So, now the other thing we talk about, if you guys remember from what we've always done, GIF, for example, our standpoint is if we had a parapet wall, doesn't matter the size of it, it didn't matter. We still had to have perimeter enhancement. The bright side of this of 7-16 is if you have a parapet wall that's 3 feet or higher around a building, we do not need zone 3. So just for an example, on this building here, this building has a parapet wall around 3 sides of it. Steven's going to be drawing this in to help me explain this to you guys. So here's our building. On this edge here in the blue line, this is going to be our drip edge. So we've got a gutter there or just a drip edge, whatever the case may be. But the surrounding 3 walls, we have a parapet wall that's 3 feet or higher. Now, we don't need enhancements around where those parapet walls are. The only place we need them is at the very bottom where that drip edge is, which Steve is going to draw in for us right now. This is where we're going to need that L shape. This is where you're going to have to do your equation to make sure you have this installed. Oh, he's getting his eraser out, Gino, again.
The eraser?
He's just showing off all there. He's got his pencil. So right here in this area, we're going to have that L shape here and an L shape at the other end.
And if they think it's bad on the computer, his drawing is even worse live, buddy.
Is it?
I've seen it. Can you see us on both cameras now, Mr. McCabe?
You there, Steven? Are you on mute?
Yeah. Is it on mute again?
Yeah, it's both cameras.
All right, cool.
All right, cool.
Sorry, guys.
So any questions on that? Clear as mud? Apparently, we got a question here or an answer.
It's the same one, but
Same one?
Yeah.
Okay.
So,
any questions, Mr. McCabe? No, we're good, right?
yeah, I got to help out Jack when you guys go live, so I haven't done that yet.
Okay.
So.
Perfect.
Again, he's multitasking.
Okay, so we mentioned zone 1 may change. So zone 1 prime, remember I mentioned at the very beginning, may or may not have an impact. So let's take a look at this building, 3 different buildings. They're all going to be the same size, 100 feet by 200 feet. But now we're going to change the variable of 30 feet, 45 feet, and 60 feet in height. So if you look at the first building, that's kind of like the example we've been doing. So zone 3 is 18 feet by 6 feet for zone 3. Zone 2 extends in by 18 feet. Zone 1, 18 feet. And then whatever is left, which in this example is 28 feet, is your 1 prime. But now, when we get to a higher building, 45 feet, you can see zone 1 prime disappears. Because it's higher, we're going to take 0.6 of that 45 feet, we get 27 feet. And so now zone 2 will go extended to 27 feet, and what's left over is only enough for zone 1. Lastly, you have 60 feet in height, and, well, as you can see here, now we have a much smaller zone 1, and most of the building is going to be based on a perimeter because it's now 36 feet is 0.6 of the height. So a lot more enhancements based on the height of the building. Now, zone 1 won't always exist, especially now if we take the width of the building to change. So now in this example, we're going to do 30 feet high. This is the same example we've been talking about, right? 30 feet high. But now we're going to look at 60 feet wide, and now you can see 1 prime gone, right? It disappears because the 0.6 of it is 18 feet on each side. Whatever's 18 feet with zone 1, you don't have enough, so zone 1 prime is gone. Now, if we get to 30 feet wide, now we don't even have zone 1, okay? Because, once again, the width of the zone 2 is going to be 18 feet, and you need it on both sides, so 18 feet plus 18 feet gives you 36 feet, and the width of the building is only 30 feet. So, as you can see, that either the width of the building may change it or the height of the building, so you need to keep that in mind. Now, there are a couple questions. So, Jack had a question, parapet walls. A lot of roofs at the gutter edge have a parapet that jog in and anywhere from like 2 to 20 feet. Does the parapet have to extend the entire length of the corner for it to not be a corner?
That's going to be difficult to answer, Mr. McKay, because it's going to be a job-by-job basis, right? But the way I look at it, if it jogs out and it's less than 3 feet on one side, and I get it jogs out, but wherever it's less than 3 foot, just for us to be safe, I would always put my L shape, because once again, we run into the city worker.
I think we're going to kind of talk about that with the odd shape building.
Yeah.
And that may answer some of his question.
Yeah.
Maybe we might get Joan involved in that when we start talking about that.
Yeah, because
So hold sit tight. I think we're going to get there.
Yeah, what Chino said is right. What Chino said is right. The entire area, the roof zone, it has to be encapsulated by a 3 foot or taller. So.
Yeah, like Wally just said, we will show it on one of our mock-ups, guys. So, and hopefully we answer. If we don't, Jack, go ahead and throw us another. We did not hit the answer. So, all right. Anything else, McCabe?
Good question.
Good one, yes.
No, I think he was just following up with that same question. So, last bit is going to be corners. And, where are we going to have that zone 3? So looking at this, is not all corners are going to require the enhancements or that zone 3. So rule number 1 is inside corners do not require corner enhancement. So I'm going to point out, you can see that one area right here. It's an inside corner, so no zone 3 at that location. Now the second one, outside corners with an offset less than 0.6. So in this example, we've been talking about 18 feet needs to be the number, but you can see this offset over here is 15 feet. So therefore, you do not need zone 3 there because you can't get to your 18 feet. And also outside corners with an angle greater than 135 degrees. So what that means is, let's take an example, is the one near the bottom middle. You'll see on the right hand side is this one requires zone 3 because it's less than 135 degrees. It's greater than 90, but it's not greater than 135 degrees, so we're going to need zone 3 there. But if you take a look at this one is now greater than 135 degrees, and so therefore we need no zone 3 at that location. So a couple things that we want to keep in mind. Now, Chino, do we want to show the diagram, or do you want to just go right into that layout?
Let's go right into the layout, because I think this is more easier to understand here in the layout. And once again, Mr. McCabe, with the layout we're doing here, I just want to remind everybody it's going to be our RhinoBond layout, what we're doing here. But what's cool about this, right, Wally, is eventually we're going to give you
some
some
hybrids.
Yeah.
So we're also talking about RhinoBond. But again, guys, we're at the end when we get talking strictly about RhinoBond, we're going to show you guys some hybrid systems. which may or may not help you guys with your installs. We're gonna be talking about RhinoBond and mechanically attached in the same breath here. So just bear with us and hear us out. If you got any questions, again, feel free to ask them.
So Wally, before we start, we're basing this off of what, a 30-foot high building and less than 100 by 100 foot, right?
Right.
Okay.
So this is our magical, because I don't know, you only refer anything square. I don't mess with them angle buildings.
No.
So guys, this is RhinoBond. Chino went over the how many fasteners you're gonna need per board. Now, those of you not familiar with RhinoBond, we have other classes to actually go over this. We're not going to talk about sheet layout per se. We're talking about the attachment. We can get into sheet layout, we just don't have the time today. And there's ways to lay out RhinoBond sheet that's more advantageous to you and your crews. So if you look at this, Chino, and people in class are going, they're going to think, these guys don't know what they're talking about. What is wrong with this insulation pattern?
Well, it's not staggered.
It's not staggered. So again, guys, this is GAF, okay, we're talking about, and if I'm your foreman, this is the way I'm going to lay out my RhinoBond insulation. Now, something you have to remember, if I have multiple layers, I'm going to be staggered off the bottom layer. And we asked this in the class yesterday, why do we stagger insulation? It's for thermal bridging. So if you stagger off your bottom layer, you're going to help eliminate that thermal bridging. The other reason is you're laying out RhinoBond plates. Remember, they have to be in a pattern. You got to be able to find them. I got a roll of RhinoBond plates this way, and I got a roll this way across this entire roof.
So pretty much doesn't matter which way I'm going to attack this, right? They're all lined up perfectly. And I won't lose track of my fasteners.
Now, I would just throw this up here real quick. If I were doing a RhinoBond right there, and I staggered this insulation, and if I'm laying my RhinoBond plates out, whatever my fastening pattern is, in this area right here, across this entire roof, you're actually using more. If you want to do the math, that's fine. Over the long run, you're actually using more RhinoBond plates than you need. And plus, these areas, theoretically, you're point loading all these areas.
And the other thing too, Wally, like we were just talking about the other one, they match up this way.
Exactly.
But they don't match up.
And you got to try and find them this way.
So yeah, so that's one of the reasons GAF guys, once again, we don't stagger the top layer for our RhinoBond system.
So again, so here's our 30-foot high building. Now remember, if it's 30 foot high, our length is going to be how long, Chino?
18 feet.
How wide are we going to be?
We're going to go 6 feet.
6 feet. So if you can zoom in on this is the scale. So I've got 8, 16. How long is that, Chino? 24. Oh, you're
24.
You're doing math again.
24.
So I'm actually longer than I really need to be. Again, could I take this and split this board? Sure, I could do that. Then I got to do it up here.
Yeah.
Because I'm 8 foot here, I only need to be 6 feet.
And once again,
4, 8, 12, 16,
20.
So I'm actually a little longer than and I'd actually have to split the board here.
And once again, this is easy to see here, but when you're on the roof,
yes,
it's
we're looking at it as we're floating over top of the building.
Yeah.
If you're on the roof looking at this, again, this is up to you and your crews. We're not telling you you have to do it this way. We're trying to give you an alternative to lay this out.
It's just a lot easier for me on the roof, brother, right?
And again, up here, we got the same thing. So actually, just worked out good because I'm 4, 8, 12, 16. There's my 18 foot right here. So actually, just the way this worked out is I had a 2 foot piece to finish off this job. So here's our L shape, our zone 3, our zone 2, our zone 1, and our zone 1 prime was so small, we just said the heck with it and just filled it in.
So, is there any questions with this one, Mr. McCabe? With this layout on this one, right?
I mean, it looks really busy. We get it, guys. You're looking at this going, holy crap. But imagine if this was a 1,000 square job, the fasteners you would have on this.
No questions right now.
So, Wally, once again, we always try to do whatever we can to make it easier for the guys, right?
Exactly.
So, 2 days ago, we talked about mechanically attached.
Right.
Now, I myself, we think this might actually take off, right?
Yeah. Now, we're going to kind of get into the weeds a little bit, guys, to help you, again, deal with 7-16. So, now we're going to kind of talk about what we like to call hybrid systems. And like Gio said, this is my personal opinion. If you were on the adhered session yesterday, you saw the amount of fasteners that was involved with that. You saw the amount of fasteners that was involved with with RhinoBond. So what we're going to throw at you here is kind of a combination of RhinoBond with mechanically attached. If you're new to RhinoBond, I highly suggest you take one of our classes or any class to understand the system, to utilize this when you're doing your roof layout. So what we have here, I'm sorry.
Real quick, going back to the other one, if you want to pull off that sheet real quick, is Anton had a question, is for the top layer, isn't it better to have a 4x4 sheet?
Oh, 4x4.
No, that's just more handling for us. This is just for me, McCabe, is I got to use more fasteners now, right? Because you got to understand. So I'm going to zoom in a little bit. Well, this one actually shows it perfectly right here. So do you guys see this right here, this board right here, for example, Steven?
Yes,
Right?
sir.
I have my 9 fasteners. So I got to split this board in half. So if I use a 4x4, I actually got to put three more fasteners here and 3 more fasteners here. So I just added more fasteners to this board, right? Same thing with here. Added more fasteners to this board because I cannot split. Put a fastener in between two
Try to
boards.
hold down two pieces of it.
Yeah, I can't do that. So I just added more fasteners and more labor, right? And then handling all 4x4s.
Well, and you can throw another taper. You put a taper system on top of this. I mean, we don't have a lot of time.
We're going,
Yeah.
So yeah, we're gonna actually do.
Oh, hang on a minute. If they want to use 4x4s, we'll sell more plates. We don't have a problem doing that.
But not for Anti. She's one of us.
She's a salesman. Yeah.
She sell more. Yeah. So yes, Anti 4x4s work.
No.
So no, but it just makes more work, right? More fasteners, more labor, and that's what we're trying to help you guys save on is labor.
I will ask anybody in the audience that's an estimator or business owner what costs more to job, material or labor.
I hope that answered that question.
Yeah.
We good?
Yeah, and Buddy says it's very easy to follow your layout that you had last time.
Cool. All right, so jumping forward. Now, guys, this is.
Hey, you guys went mute. We can't hear you.
Steven.
Oh, crap.
There you go. It's back up.
All right.
Okay. So again, guys, this is underneath. These are all 10-foot sheets. Okay.
Mechanically attached, right?
Mechanically attached. So we're incorporating. So all these seams here have screws and plates, and all these seams. What you're seeing here is RhinoBond plates underneath this system.
So the first day we talked about going through the membrane.
Through the membrane.
The only thing with that is we got to strip it in.
So yeah, if you go through the membrane mechanically attached, are you really saving that much time?
No,
Because now you've
doubled my seams.
doubled your seams. So here we
With
can
our
actually
RhinoBond.
we can actually install the RhinoBond plates in our insulation, kick our sheet back, come back and find those,
And then
zap through the membrane.
and it's all 10-foot sheets.
10
It
foot
looks
sheets.
nicer as as a building owner that wants to see that, right?
So again, we've got then we'll talk about the L's and why we're coming in a certain distance here.
All right. So pretty much, guys, we still have our 3 zones, right? Well, technically it could have been our prime, but we decided it wasn't worth it with the size of our roof, right?
Correct.
So now here again, Wally, we got our 5-footers right based out here because we need our 5-footers no matter what, right?
Correct.
So that's what the RhinoBonds did, right?
Yep.
Now we go with our enhancement in the corner, and Miss Jones maybe gonna talk a little bit about this as well.
Right.
So all we did, guys, is we did beef up our corner. Remember, we have to beef up our corner. But once again, Miss Jones gonna talk about that.
She's got some slides.
Some slides, yeah. So I don't want to steal her thunder in a way, but once again, we still beefed it up. This is mechanically attached with RhinoBond.
System.
And me and you being installers, to me, this is actually pretty something I'd be looking forward to.
So again, looking at this, so this looking for comparison underneath, fasteners we put into a full RhinoBond system where I can incorporate mechanically attached in with it, eliminate a lot of this work.
What actually helps out too, Wally, is when we show the 5-footers all around that whole perimeter. It's kind of crazy, right? So this is one option, right?
Option one, exactly.
now this is something that I kind of like a little bit better, just because I don't want to find or try to, it's mixed, right? Mr. Mark Lenman, he loves RhinoBond 10 footers, right?
Right.
So what did we do different here, brother?
So now we actually installed our 5-foot mechanically attached half sheets, if you will, covering our 18 feet. Actually, we're going to be 20 feet, but we're going to beef up our corners. So these are 5-footers. Then we go to 10-footers, incorporating our RhinoBond plates underneath this.
So we just eliminated the RhinoBond plates here, right?
Correct.
So we just went straight with the 5-footers. We're fast. Granted, we do got a little bit more seams, but for guys that are not used to doing that whole hybrid thing,
Well, the other thing
makes it
is,
simple.
if, like a mechanically attached, where you can actually take 5-footers and take 5-footers all the way around this building. Remember, a mechanically attached, you have to go perpendicular to the roof deck.
Yes.
If my roof deck is running this way, this way, these 5-footers, if my roof deck is running, say this is north and south, if I were to take 5-footers and run this way, I would be actually running with that deck.
Point loading.
Point loading that deck.
And then so that's the other problem.
Now I'm distributing load across the deck.
And like you said, this is something that we've been liking a lot, right?
So this is another option.
Any questions with this one, Mr. McCabe, or anything? Everybody's good?
Yeah, if you got any questions, please use the chat box. Any comments? Hey, if you need to make fun of Chino, we appreciate it as well. So anything you want to put in the chat box.
Man, you guys are solid on this one, aren't you? So, guys, someone asked questions a little bit about our corners, right? So I hope this answers a little bit. I know McCabe kind of went through that little slide to talk about our corner. Oh, I'm off a little bit, Wally. Hold on. So, once again, guys, we kind of did this a little bit. So where Wally's hands are, we're going to imagine all that is a 3-foot high wall, right? So technically, we don't need
Our enhancements in this
our corner enhancement.
Here.
But why do we need it where your hand's at, Wally?
So this would be basically your drip edge.
Okay.
So like we showed in the picture, I don't have a wall here. I do over here, but it doesn't matter since this is exposed to the wind, same as down there. I need it here.
So the one up top, right there, we don't need it just because it's a 3-foot wide. Yep.
So why don't I need any enhancements down here, Chief?
So the reason we don't need it here, once again, guys, it doesn't offset with our 18 feet. Once again, it's offset. This is actually like, what was this, Wally? Was it like 6 foot? 6 foot. So that's why we didn't need it here or here, because it doesn't match up on this corner or this corner.
So something that we should cover here too, Chino. How many half sheets do we have here? 1, 2, 3, 4.
4 half sheets.
So what does it look like we have up here?
So this is the way that our roof is designed.
5, because we have 5 half sheets up here.
So it's technically 4 half sheets and 1 filler.
So why couldn't I just keep in my full sheets and I just run a 2-foot piece up here and call it a day?
You can, but you have to install RhinoBond plates, right? So here, we always need our half sheets always at the edge of the building. Minimum.
4 foot.
Yep.
So odds are you're going to be 5-footers or 6-footers in today's world.
Yes. So that's why, but I'm glad you brought that up, though. But at the same time, Wally, here we're using 5-foot sheets.
Right.
Actually, our number of TPO rolls could actually minimize if we start using 6-foot sheets as well.
Exactly. 6-footers or 12-footers.
Perfect. Any questions, Mr. McCabe, before we let Miss Joan do her thing?
No, it looks like so far, you guys have nailed it. So,
or everybody's sleeping,
or we confused the heck out of them and they logged off. So,
well, I don't know. I mean,
question.
You guys are doing a great job, but I got to tell you, I'm still a little confused, Chino. So I think we need to bring in the experts.
Somebody a lot smarter than us.
Exactly. So let's.
Joan, someone's behind you.
Joan.
Thanks, guys. Again, embarrassing. So, first off, I apologize. I am not going over the hybrid system, so you guys are going to have to tune back to go over the hybrid. I didn't think I had enough time because I knew you guys were going to run over on this one, showing your mock-ups. But so I'm just exclusively showing RhinoBond.
So what are you saying? We're like long-winded or what?
Yeah. Hello. I've worked with you. Yeah. Yeah. No comment. And then yeah, I know. And then quickly, Jack's question about those wind speed maps. Remember, those are just wind speed. Those are miles per hour, not the pounds per square foot. They're not going to give you pressures. Okay, that's number one. And two, they're hard to interpolate, like hard to, depending on where you're located. So there is an online service where you put in your address or your zip code and you can get the wind speed. If you actually do want wind speed, I'll give it to Steve to email, okay? So we'll do that. Anyway, so let's go on for our RhinoBond example. Again, we're running short of time because the guys are so long-winded. So I'm looking at, I decided to pick Orlando for this project because right now it's snowing and I'm buried right now. I'm kind of pissed off about all this snow. So I'm like, all right, I'd rather be in Florida. So it's still 100. I'm going to pick the 100 foot by 100 foot building. That's 30 feet in height. Matches matches Chino and Wally's example. Here we go. So if you sound like a broken record, if you've tuned in the last two sessions, but the basic equation for wind design is you want to make sure the design wind loads, those pressures that are calculated by a designer, are less than or equal to a wind rated roof system. And how you get that wind rating is that you're testing, us manufacturers test our roof systems for the capacity they can take. So you want to make sure that what you predict in those calculations is less than what was tested in a roof assembly. So where do you get these design loads? If there is a designer working on your project as a new construction, it is required by code that that designer provide you guys on the drawings and or specifications, those, all the wind information, okay? If they did not, go back to them and tell them that I yelled at you and said, go get that information. You're required by code to give that to them. We don't want roofing contractors doing math. If there's not a designer, meaning like a re-roofing situation where unfortunately you guys have to kind of come up with numbers, there's some options. There's RoofNav calculator. I tend to not like using RoofNav calculator if it's not an FM project because they're going to give you higher pressures than normal because it's an insurance company. And FM wants to make sure that a roof system that they determine for you is going to make, they want to make sure it's not going to blow off, right? So they kind of bump up the numbers. So keep that in mind if you're using RoofNav. Yes, you have to use it for FM insured, but if you don't, I tend to shy away from using that. NRCA, the National Roofing Contractors Association, has Roof Wind Designer, which I helped develop. It's a very simple approach. We designed it for roofing contractors where it's a step-by-step approach into determining wind load pressures. But here's the thing. It is for very simple buildings, but at least you can go up to 160 feet in height. So just keep that in mind. And if you have a very complicated building and you can't do math, I would suggest hiring a structural engineer. So for our example in Orlando, I ran some numbers because I like to play a structural engineer every once in a while. And I came up with these pressures, and we want to use, when we're doing prescriptive design, you use zone 1 as your basis of your design. And for this project, I came up with 81 pounds per square foot. So where do you find these wind-rated systems? Believe it or not, there are 6 listing services in the industry. Everyone's very familiar with going to RoofNav assemblies, but that is not your only choice, and it's not required unless it's an FM-insured building. Spry, the single-ply roofing industry, came up with DORA, and not the Explorer, where it's the directory of roofing assemblies. I find it a very easy-to-use interface to find roof systems. The only negative thing about it is that you're not going to get the million assemblies that RoofNav has, but it's a good starting place. UL has a system, but it's really hard to use, so I don't recommend it. And then if you're in the Gulf Coast area, again, I'm not sure where our audience is, but most likely you are familiar with the Florida Building Code product approvals in Miami-Dade County and TDI's listing service. But like I said, unfortunately, RoofNav is the mostly used. And for my example, I ended up going to them as much as I hate it. So you want to go to Assembly Search. And when you select, FM bases their roof systems, they're called the 1-whatever, and they start minimum at 60 pounds per square foot, and they go in the 15-pound per square foot increments. So this should be pretty familiar where you see a 160, 1-75, 1-90, 1-05, and so on. So going back to our design values, again, we're looking at zone 1, which is 81 pounds per square foot. So it looks like we need a 1-90 because 90 is greater than 81, but we don't need to go to 105, right? So I go looking for a GAF assembly that meets a 90, and again, I get like 5,000 hits, but I picked one. And when you select it, you'll see this information that says contributory area. Okay, so that means a fastener helps, this is the amount of square footage per fastener you want to think about. So for our 1-90, it's 5.33 square feet. So for a 4x8 board, again, simple math, you need 6 fasteners per board, which everyone should be pretty familiar with. So for our, what I call interior and exterior field zones, 1 and 1 prime, and because our building's so small, we're just going to ignore that 1 prime. We're going to use 6 fasteners per board in that field area. And now let's look at prescriptive enhancing the perimeter and the corners, or zones 2 and 3. Again, more math, and if you were with me yesterday, it's the same math. So for perimeters, you're looking at 67% of that fastener area that we use in zone 1. So 67% of 5.33 is 3.57 square feet. So when you do the math per board, that ends up being 9 fasteners per board. Corners, it's 50% of the zone 1 fastener area. So that means we're at 2.67 square feet, and that ultimately means 12 fasteners per board. And my drawing perfectly matches what Wally and Chino have, where we're showing the L shape, where if a board crosses the border, you can either install it, you should install it to the higher fastening pattern, or if it splits nice and even, you can split it up. But anyway, that's all I have for today. Again, trying to meet the time frame that I had and leave time for questions. But thanks, guys.
I blame McCabe on that, Joan.
Well, you didn't think we were going to draw. We were going to make something that didn't match your drawing, did you? No,
That'd be crazy.
That would be too coincidental. But thanks, guys.
All right.
Thank
Thanks,
you.
Joan.
Thank you,
So,
John.
Mr. McCabe, we actually got a pretty good question
Jack.
from Jack. He was asking if we could pretty much use our fasteners that hold on the insulation on the RhinoBond as our base attachment or for our angle change. Want to answer that, brother?
So, very good question. I'm glad you brought that up, Jack. So this is our RhinoBond layout. Okay, you see my RhinoBond plates running. Again, there's ways to lay up your sheet. We have classes on this. But you see these pink, might be tough to see. Then this is our base attachment for our flashing. In lieu of an RTA strip or alternative base attachment. You can actually use your RhinoBond plates for your base attachment to do a wall flashing.
A lot of guys make that mistake and use the fastener.
Yeah, they think, well, I'm close enough, like right up here. Why do I need them? I can use that. No. You have to have separate base attachment.
Yeah, separate base attachment.
That's getting into sheet layout. We do cover that in other webinars.
So I hope that answered it, Jack.
Yeah, it looks like it. Okay. So while we're waiting, I'm just going to go over a couple of last points. Remember, when we're looking at it in the field, there are a few key takeaways. Remember the formula. We've pounded the formula a lot over these last 3 days. 0.6 of the height is going to be the length of the corner, the perimeter width, zone 1 width. So it's going to cover that. 0.2 of the height is going to be the corner width for the zone 3. Remember parapet walls. If you have parapet walls greater than 3 feet, you do not need any corner enhancements. And lastly, corners. No inside corners, no outside corners of less than 0.6 of the height, where the offset is less than 0.6 of the height, I should say. And no outside corners if greater than 135 degrees. So we're going to stay on here a little bit longer if you have any questions. Now, I just put in the post in the chat, the document again that I shared at the very beginning. This was written by Joan, so huge amount of information. That's your takeaway. So if you want to click on that, save it to your favorites. It's what we use to help develop this training. So just huge amount of information in there. Can't thank Joan enough for just an awesome job on that and the help that she did provided for these trainings. I also have a survey in the chat box. It says www.getfeedback. This is for Chino. Chino was actually the mastermind of developing this training, so well done, Chino.
Blaming you for that? You hear that? He's blaming
He's
you.
doing so good. I'll give him a gummy bear.
So if you can do that, it's a really short amount of time, and also one of the cool things on it, we'll ask you what your position is and what future trainings you would like to see. Last but not least, Joan put in a link to the service that will determine the wind speed mapped by the address. So once again, thank you, Joan. So you can see that hazards.atcouncil.org. So check out that link. That is huge. So key takeaways. Here's the key takeaways one last time. And with that said, what we will be doing is we will be going over the train by self. So if you want a training certificate saying, hey, I've been factory trained by GAF so I have a 3,000 foot view of ASE 7-16, you can get that certificate coming up shortly. Also, if you want training credits, if you're a master, master select, master elite, and you want your training excellence awards, this is the way to do it. So, with that said, Zach, if you need more time, just let me know. I'll come back to that. But just for the sake of time, I'm going to show everybody the 3 ways to register. So, number 1 is you can hold up your phone, open up your camera browser to the QR code. And if you have an Apple phone, a link will pop up. Don't take a picture of it. Just click on that link. If you have an Android, though, unfortunately, you will have to take a picture of it and then load it into your QR reader. Option number 2 is you can click on that link, and I'm adding that right now. So you can click on that UL code. And the third option is you can send a text message. So I'm going to put both of those in the chat box right now. So both of those, very easy, click on that URL link. You can go directly to the registration or send a text message to 56512 and then type in capital S, capital M, QT, Q2, VVZ. So yes, they work on tongue twisters to get the code, so try that out, say that about 5 times. So RhinoBond, what we're going to be looking for to get your certificate is your company name. So once again, if you're a Master Elite, Master Select, or Master, you got to start typing in your company name and then look how it populates and find the correct one. Okay, if you're not a JAF contractor or not a Master Elite or your distribution, it doesn't matter. Just type in your company name as you normally would. Okay, that's only for training credits. Now, for your certificate, you will need your first name, your last name, and of course, for both of them, and especially for the certificate, you need that email. So those are the 4 things we're looking for. And then when you're done, you can see what this will pop up on your screen. So this is something great to add to your phone because, hey, I want to know GAF specs. I can go to the manuals and pull up the specs, the Pro Field Guide, and get more help on this. I can pull up videos. I can find out what the next courses are. I get questions all the time. Hey, what's the next webinars you're going to do? Just click on that link, and that will give us to the webinars. Contact us. This is going to go to this page. You type in your zip code. You'll find out who your local GAF representatives, so they can help you out. And a lot of them, I tell you, just have a wealth of knowledge. So reach out to those. And last but not least is the Learning Portal. The Learning Portal has tons of great stuff. It has e-learning, it has videos, and it has some of our pre-recorded webinars. You can see here Scott Dawson, Mitos Fuentes, our Shingle Whisperers installing a power event. And then you have Wally and Dave Scott, Weapons of Mass Destruction, installing a TPO roof in a parking lot. So they kept that parking lot dry on that one. Last but not least is the Learning Portal. So how to get there is www.gaf.com/learning. Type in the branch code GAF. I will warn you, these webinars this week from the ASC 7-16 will not be added. Joan will be coming back in the future to do another webinar on it, and that will be uploaded to the learning portal. So it looks like we have another question from
Anton?
somebody raised their hand. I guess they put it down.
Well, Anton had a question too about RhinoBond classes in Chicago. We can set it up. I mean, Steven is our agent. Set it up with him.
But as of right now, we're not really doing live training right now, guys. It's all going to be webinars.
We want to, trust me, we want to be in front of you guys face to face, but
We do. McCabe actually loves doing this. He says that he's going to be doing this.
I'm sure everybody out here is probably sick of webinars. We'd rather do a lot, but we can do a webinar on RhinoBond. Anything you guys want, just we can set something up.
Hey, Chino, I was talking with higher up. Your face lends itself very much to the camera, so we're keeping you on, and Wally and I are going out to the field. So,
Boom. See ya.
I'm going to come down with COVID, guys. I'm leaving now. No, we're good, brother. We'll try to get you. Once again, Mr. McCabe, right? There's more webinars out there, and if they want something specific for their company, they can get in touch with their sales guy, and we can set something up for a future webinar.
Yeah, if this is your first experience with RhinoBond, definitely, we could do a class and show you how to utilize it.
absolutely. Well, if there's no other questions out there, hey, we really appreciate you taking the time to join us these last couple days. If you've been on multiple or today. We hope this was useful. Once again, it's a 3,000-foot view. We wish we could go into exact specifics on every single thing, but as you can see, it doesn't really lend itself, unfortunately, as much as we would like to. So hopefully you got something out of it. You learned some tricks of the trade with Chino and Wally. And my final parting words is stay safe and stay warm out there, because, dang, there's a lot of snow coming down.
There's only like 5 or 6 states that aren't covered in snow right now in the whole country.
Thank you, everyone.
Thank you.